Hello, good day. In this video, I'm going to explain about Semiconductor Lab with the title Diode Application as a Switch. Learning outcomes for this lab are: first, to construct the diode in forward and reverse bias connection. Second, to measure voltage diode and current in forward bias. Third, to measure voltage diode and current in reverse bias. Last but not least, to complete the table 1 and table 2 during the observation of LED in forward bias and reverse bias. Equipments for this lab are diode with IN 4001, IN 4002, IN 4006, and IN 4007. Resistor 100 ohm, jumper wire, clip, crocodile clip, battery 9 volts, and analog multimeter. If you are using digital multimeter, it should be okay to use in this lab. The operation of a diode as a switch theory. A diode is a two-terminal PN junction that has many applications. An electrical switch is one of these functions. When forward bias, the PN junction operates as a closed circuit, and when reverse bias, it acts as an open circuit. As a result, switching between forward and reverse bias states causes the diode to function as a switch, with forward being on and reverse being off. In forward bias connection, the cathode connected to the positive terminal of the battery, whereby the anode connected to the negative terminal of the battery. In reverse bias connection, the positive terminal of the battery connected to the anode, whereby the cathode connected to the negative terminal of the battery. Experiment procedures. First, connect the circuit as shown in figure 1. Measure voltage at D1 and current in the circuit. Next, record the result at table 1. As a result, in forward bias connection, the measured diode voltage is 748.17 mV, whereby current measured is 36.54 mA. The condition of the LED is on. The picture shows that battery is used as a DC power supply. The picture shows how to construct forward bias circuit and measure voltage at diode D1 using analog multimeter. The analog multimeter is connected in parallel connection with D1. The picture shows how to measure current at diode D1 using analog multimeter. The analog multimeter connected series with the diode D1. Now reverse the polarity of a diode as in figure 2 and then measure voltage at D1 and current in the circuit. Next, record the result at table 2. Based on this experiment, diode voltage is 9 volt and then the current is 0 ampere, whereby the LED condition is off. This picture shows how to construct reverse bias circuit and how to measure voltage in diode. As you can see, the analog multimeter is connected parallel with the diode. The picture shows how to measure current at diode D1 using analog multimeter, and the analog multimeter connected in series to D1. So next, let's discuss question number 1. Does the current flow in forward bias direction? With the help of a diagram, explain and relate your result with the theory diode in forward bias direction. Does current flow in forward bias? Yes, according to this diagram and the principle of the diode as a switch, the current flows in a forward bias direction. To connect the diode in forward bias, connect the cathode terminal of the diode to the negative terminal of the battery and the anode terminal of the diode to the positive terminal of the battery. Because the diode link in forward bias in the circuit that has low resistance, current can flow through with little to no voltage in the diode when measured. When a diode in forward bias and behaves as a perfect conductor with zero voltage across it, it is considered to be an ideal diode. Discussion question number 2. Does the current flow in reverse bias direction? With the help of diagram, explain and relate your result with the theory diode in reverse bias direction. Does the current flow in for reverse bias connection? The answer is no. Based on this diagram and the principle of the diode as a switch, the current does not flow in reverse bias. To connect the diode in reverse bias, the cathode terminal connected to the positive terminal of the battery and the anode terminal to the negative terminal of the battery. The current does not flow in reverse bias because it serves as an open circuit with a very high resistance that prevents any current from flowing through it. As a conclusion, a diode acts as an open switch or off in reverse bias and closed switch or on in forward bias. This is due to the fact that when the diode is in forward bias connection, which is the cathode terminal of the diode is connected to the negative terminal and the anode terminal is connected to the positive terminal of the battery, the diode has little to no resistance and current can flow through the circuit, allowing the LED diode to light up or to turn on. When forward biased, an ideal diode acts as a perfect conductor, allowing no voltage to flow through. Furthermore, as proved by the experiment, a diode may work as an off or open switch and acts as an open circuit when linked in reverse bias. For a reverse bias circuit, connect the cathode terminal of the diode to the positive terminal of the battery and the anode terminal of the diode to the negative terminal of the battery. When the diode is linked in reverse bias, it acts as an open circuit and has a high resistance. Because of the diode has higher resistance, no current will flow through and the voltage value of the diode will same as the voltage of the battery. In completion of this lab, you should be able to construct the diode in forward and reverse bias, to measure voltage diode and current in forward bias, to measure voltage diode and current in reverse bias, as well as to complete Table 1 and Table 2 during the observation of LED in forward and reverse bias. Thank you.